Okay, 9.2. In 9.2, we looked at simplifying with trig identities. And so at the top of your notes, you'll see all of, I shouldn't say all of, but a lot of the trig identities that we use, especially I would say the ones that we're going to be using in this particular lesson. And so in the first box, you see your different reciprocals, that sine is the reciprocal of cosecant, so therefore cosecant is the reciprocal of sine, and et cetera, through cosine secant relationship and tangent cotangent relationship. You then have a reminder of what tangent and cotangent are in that middle box. Tangent is sine over cosine, cotangent is cosine over sine. And then opposite angles, which are the ones in class at least that people seem to not remember as much as the others, which is that when you have sine of negative theta, that's equal to negative sine theta. Tangent of negative theta is equal to negative tangent of theta, and cosine of negative theta equals cosine of theta. And the reason for these relationships all hinge on the quadrants that your angles would lie in. So for example, if my theta here was, we'll say 30 degrees, on the right side there we have negative sine theta. Well, if, again, whoops, I'm going to try 30. Negative sine 30 degrees. If we were to draw that in, a 30-degree angle, something like this, and were to calculate its sine, we would know that sine in that first quadrant is positive. The sine of 30 degrees, we actually know what that is. That is 1/2. And so this value here would be negative 1/2. If on the left side of the equation then, you went, okay, what's the sine of negative 30 degrees? Well, negative 30 degrees would put us down here in the fourth quadrant, same reference angle, so still a sine of 1/2. But because we are in the fourth quadrant, sine is the negative, and so on the left side, we get negative 1/2. And so both the left and the right would generate negative 1/2. And it doesn't matter what angle you pick. If theta lies in the first quadrant, then negative theta will always be in the fourth. And even if you went over to the second and third quadrants, so say you picked theta of, we'll go with radians for this one. We'll do 3 pi over 4 for my theta. Okay. 3 pi over 4 sits in the second quadrant there. Well, on the right side of this equation, the negative sine of 3 pi over 4, sine is positive in the second quadrant. So the sine of 3 pi over 4 is root 2 over 2. So this would be negative root 2 over 2. The negative from the front and then positive because it's the second quadrant. Well, say we were then to do the left side of the equation, negative 3 pi over 4. Well, negative 3 pi over 4 would put me in the third quadrant where sine is negative. And so this on the left side would be negative root 2 over 2 again. And so again, no matter what angle you pick as theta, you will always see this relationship to be true. Same with tangent, same with cosine. Okay, and then down below we have our Pythagorean identities. So sine squared plus cosine squared equals 1. Our tangent squared theta plus 1 equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. And then I worked out kind of really quickly a demonstration of why those are true. Just for those who don't remember why the second two identities are in fact identities, they all stem from our kind of primary one, the sine squared plus cosine squared equals 1. Because if I start at sine squared plus cosine squared equals 1 here, and I divide all of them by cosine squared, I get my second identity. And if I start with that same sine squared plus cosine squared equals 1 and divide them all by sine squared, I get my third identity. Okay. All of these are ones that you will need to have memorized and be able to recognize. Sorry, let me erase my stuff there. And then the only other thing that was initially done in this lesson, and so if you need to watch the first video for this Unit 9 Objective 2, you would want to do so, because we've already walked through all of this reminders, or all of these reminders, I'd say, with our algebra skills. Or if you don't want to watch that video, but would instead like to just email your questions, you're more than welcome to do so. But these these are algebraic skills that you might need as we continue through this second video, which is I would call new material of this particular lesson. Okay. Yeah, okay, so moving on here. Then again, what I would call new material of this particular lesson is simplifying each of the following. Now, almost every single one of these will simplify down to a singular trig with a positive angle measure inside. And so we have some steps here. Really, they're more suggestions than steps, because there isn't going to be one way through these problems, and that is going to make this lesson a little bit challenging potentially, is how you see the problem might be different than one of your peers, or potentially even different than the way that I see it. Some problems I'd say are a little bit more straightforward, but the more complex the problem gets, the more variety in routes there are through that problem. As long though as you're still plugging in actual trig identities, as long as you are using accurate algebraic steps, you should always generate the same answer no matter what route you pick. And so as you're watching this video, if you're kind of doing this for the first time or learning this for the first time, if you try it a different way than I demonstrate, that doesn't necessarily mean it's wrong. It might just be different. And so before you erase everything and change it to the way I did it, maybe snap a picture of it, send it to me, ask kind of where in your route you got off a little bit, and I can help you find your mistake, get back on track, because it's possible that route might be the one that's better for you, if that is how your brain's kind of processing the problem. Okay. Anyway, our suggested steps are to, first of all, try something. The most tempting thing to do with problems like these in Objective 2 with simplifying, or Objective 3 with proofs, is to look at it and go, well, I don't know what to do, and to freeze and to stop and not do anything. Unfortunately, you can't just not do. So then you'd be looking at your identities going, is there anything in one of those identities that looks vaguely similar to what I'm looking at? Or you'd look through some of the algebraic steps that we've kind of talked about over the different lessons and go, well, can I factor? Do I see a difference of two squares? Like, what can I do there? But you have to do something. Don't let yourself give up. After you've decided what you're going to try, some of the things to consider would be, first of all, algebraic potentials. Can you, like I said, factor? Do you see a trinomial that factors? Do you see two squares that you could do difference of squares on? Do you have two cubics where you could do cubic factoring on? Something along those lines. Do you see a distribution or a FOIL? Or FOIL for those who prefer to kind of think of it that way. Is there something along those lines that you can see? Is there a common denominator that you could find? So using kind of your fraction rules, is there something in that realm? Or could you split a fraction with a product of trig functions in the denominator somehow? And then the final thing to kind of always be keeping in the back of your mind are those trig identities. If you see a sine squared, could you replace it with 1 minus cosine squared? Secant squared, could you replace it with 1 plus tangent squared? That kind of thing. Okay? So with each of these, my recommendation is going to be, like for example, on number 8, pause the video, try to see if you can simplify that tangent x cosecant x in number 8 down to one trig with a positive angle. And then to restart the video, either when you are stuck or when you have an answer that you're wanting to check, whatever the case may be. Again, keeping in mind that there's more than one way through the problem. So unfortunately, when you do restart the video, I might not follow the exact route you did. We should still get the same answer though. If we don't, like I said, snap a picture of your work, send it to me, I'll check it for you. Okay? Okay, so go ahead and pause the video, give number 8 a shot, restart it when you're ready. Okay, in number 8, we have tangent x times cosecant x that we're looking to somehow simplify down to one trig with a positive angle inside. And so looking at these, none of my trig identities stand out for number 8. However, I do have a couple of other things I could consider with number 8. So for example, I have a cosecant. Well, I know that cosecant could be rewritten as 1 over sine. And I have a tangent, which could be rewritten as sine over cosine. And so maybe I try that, those two things. Again, not because I know they're going to work, but it's that first suggestion. Try something. Don't just stare at the problem. And so maybe I go back to cosecant and I go, okay, well, let me go ahead and rewrite my cosecant as 1 over sine. And I'm going to go back to my tangent. I'm going to rewrite it as sine over cosine. And then I'm going to step back and look at it again. What else could I maybe do to simplify this down to 1 trig with a positive angle inside, which is what most of these will do. Okay, well, so looking at this, I'm like, okay, well, multiplying fractions, I know I can cross simplify. So the sine x's can cancel. And so this would give me 1 over cosine x, which I also know that trig identity, 1 over cosine x is right here. 1 over cosine x is secant x. Okay, and so then I can go ahead and go down to number 8 and simplify it to secant x. Okay. Okay, go ahead and take a look at number 9. Pause the video, restart it either when you have an answer or are ready to get a tip because you're stuck. Okay, with number 9, there's a couple of different options that kind of spring out to my mind as I look at it. I notice that I've got a bunch of different squared elements, and anytime I see a trig squared, that always tends to bring to mind my Pythagorean identities. They're in that small elongated box. You have different cosines squareds and cotangent squareds, and so potentially I can manipulate one of those Pythagorean identities. The other thing that I notice as I look at number 9 is that I do have a GCF between my two terms. Both terms have a cotangent squared x. And so maybe I look at that and go, well, maybe I'd factor and pull out a cotangent squared x. I would say ultimately with most of these problems, any route you pick will eventually work. Again, as long as it's founded in mathematical steps. But there are definitely some routes that I would say would be faster than others. Okay. In this particular one, I would probably recommend pulling the cotangent squared out, your GCF factor. But again, it's not the only route through the problem. So say we pulled out the cotangent squared x. In my first term, what would I be left with? Left with a 1. And how about your second term? You'd be left with a cosine squared x. And so then you'd be looking, okay, well, what else could I do with this one? Well, 1 minus cosine squared x definitely, I would say, draws sharply to mind this trig identity. If I subtracted that cosine squared theta over to the other side, I'd have 1 minus cosine squared theta. And so that manipulation of our Pythagorean theorem identity, I should say our Pythagorean identity, sorry, allows me to substitute potentially into 1 minus cosine squared. The other thing you could do if you wanted, and this might lend itself well to proofs, which will be objective 3, is you could say, well, I know what 1 equals. 1 equals sine squared theta plus cosine squared theta. And so down here in number 9, I could substitute sine squared plus cosine squared into 1. Again, 1 equals cosine squared plus sine squared. And so that would be an option if you wanted to. And so that's going to go ahead and be the one that I take here. Okay, so this is cosine squared plus sine squared for my 1. I still have the minus cosine squared at the back, which is going to allow the cosine squareds to cancel, leaving me with just sine squared. Okay, well, what else could I do? Again, I'm looking at a cotangent squared and the sine squared. And so, again, a couple of different options. But for me, I see that cotangent, and I know I have a sine. And so I look at this identity here. Cotangent theta equals cosine of a sine. I go, well, maybe if I rewrote cotangent that way, that might unlock something. Okay, so cotangent is cosine over sine. Both of those are squared because cotangent is squared in number 9. And then we have our sine squared x from my simplified quantity on the right. Well, simplifying, sine squareds would cross simplify, leaving me with just cosine squared x. Okay. Okay, number 10, go ahead and pause the video, give number 10 a shot, and restart it when you're ready. Okay, in number 10, again, a couple of different options. So when I was working through this with people in class, some people saw rewriting the sine squared y as 1 minus cosine squared y. Some people saw it as finding a common denominator, so turning the 1, this one here, into 1 minus cosine y over 1 minus cosine y in order to find a common denominator. In the objective 3 notes, we're going to be reviewing how, or we will review how to multiply by the conjugate. And so potentially speaking, if you've already watched those notes or you were in class when you did that, you might choose to multiply by the conjugate to the first term, the ratio there, the fraction there. Again, all of those will eventually work. For me, when I did this one, I myself substituted 1 minus cosine squared into my sine squared, which is using, again, this identity right here, our Pythagorean identity, which is that sine squared would be equal to 1 minus cosine squared. So then coming down here, my sine squared, I did 1 minus cosine squared y into the sine squared. Okay, the reason I liked that route is because 1 minus cosine squared then are 2 squared terms being subtracted. So that in the numerator there, that is a difference of 2 squareds. We would have 1 minus cosine y and 1 plus cosine y if I were to factor that numerator. The nice thing about factoring your numerator that way is it will then be able to simplify, giving me 1 plus cosine y minus 1, which is just cosine y. Okay. Okay, number 11, go ahead and pause the video, give number 11 a shot, and restart it when you're ready. Okay, in number 11, most people, I would say, when we worked through this one in class, chose to find a common denominator. That's also the route that I myself picked. Other options would be potentially doing some sort of substitution. Maybe it would factor something along those lines. Honestly, I did not work that out because, like I said, in class, most people went with the finding a common denominator. But again, if you tried a different route, take a picture of it. I'm more than happy to check your work for you. Okay, but if we, I guess I'm then throwing this in. If you've already watched the objective 3 notes, or if you were in class, you could also multiply by the conjugate if you wanted to, which is essentially what we're going to be doing when we find our common denominator. So finding the common denominator, the second term needs to be multiplied by secant x plus 1 over secant x plus 1. The first term needs to be multiplied by secant x minus 1 over secant x minus 1. And so now my first term will be secant x minus 1 all over secant x minus 1 times secant x plus 1. And then the second one is going to be secant x plus 1 all over secant x minus 1 times secant x plus 1. And so now they have a common denominator, which means I will be able to combine these. Now, careful when you're combining your fractions because there's a minus here. You need to make sure that minus gets distributed to both terms of your second fraction. So this will become secant x minus 1 minus secant x minus 1. all over. And in the denominator, we do have a like denominator. And so if I were to write that, we would have secant x minus 1 times secant x plus 1. Okay, which this then would simplify because the secant x's would cancel. And then if I FOILed the denominator, simplify to -2 over secant x times secant x is secant squared x. Secant x times 1 is secant x. -1 times secant x is negative secant x, so they'd cancel each other. And -1 times 1 is -1. Okay, so then you're like, okay, well, I'm still not down to that singular trig positive angle. And so then I'd be looking at, okay, what else could I potentially do here? Well, that denominator secant squared x minus 1 looks suspiciously similar to this Pythagorean identity in the middle there with our tangent squared theta plus 1 equals secant squared theta, because if I subtract that 1 over to the other side, I'd get that tangent squared theta equals secant squared theta minus 1, which is what I have in the denominator of my current problem. Okay, so in the denominator there, that secant squared x minus 1 is technically tangent squared x. Okay, well, what is 1 over tangent? 1 over tangent is a reciprocal of cotangent. And so that 1 over tangent that I have in my current problem is going to end up becoming cotangent. And in this case, it'll be cotangent squared. Okay. Okay, number 12. Go ahead and pause the video. Restart it when you're ready. Okay, number 12. I would recommend making your first step foiling these out. Careful with number 12 that you don't distribute the squared. These two terms are 2 minus cotangent theta times 2 minus cotangent theta, right? And then 1 plus 2 cotangent theta times 1 plus 2 cotangent theta. It's not distributing the squared. You're actually foiling both of these quantities out. And so when you FOIL the first one, you get 2 times 2, which is 4. 2 times negative cotangent and 2 times negative cotangent, which is -4 cotangent theta altogether. And negative cotangent times negative cotangent, which is positive cotangent squared. Okay, in the second term, you have 1 times 1, which is 1. 1 times 2 cotangent and 2 cotangent times 1, which is a total of 4 cotangent theta. And then 2 cotangent theta plus 2 or times 2 cotangent theta, which is 4 cotangent squared theta. Okay, and so this will end up simplifying. The -4 and 4 will end up canceling, giving me 5, because 4 plus 1 is 5. And then cotangent squared plus 4 cotangent squared is 5 cotangent squared theta. And then you'd step back again and go, okay, what else could I do to this one? Okay, well, in this one, I could factor 5 out. 5 times 1 plus cotangent squared theta, excuse me, which is one of our identities up top here. Erase some of my marks from earlier. Okay, 1 plus cotangent squared is the same thing as cosecant squared. And so back down on the problem I'm on, 1 plus cotangent squared is going to end up simplifying down to 5 cosecant squared. Okay, we're actually going to do number 14 next. 13 is going to be the last one that we do. So go ahead and pause the video, give number 14 a shot, and restart it when you're ready. Okay, with number 14, this is the first one that we've had that has that negative x component. And so you have a choice to make here. You actually don't have to take care of the negatives right now if you don't want to, but you can, because we know a couple of identities with our opposite angles here. When we have a sine of negative theta, then that is equal to negative sine theta. And when we have a tangent of negative theta, that is equal to negative tangent theta. And so what I could do down here if I wanted is right now rewrite the sine of negative x as negative sine x and the tangent of negative x as negative tangent x. Nice thing about this is it will allow the negatives to simplify, excuse me, leaving me with sine x over tangent x. If you don't take that step now, you will have to towards the end of the problem. Okay? Okay, so simplifying at this point, you're looking at it going, well, I don't know, but I do know that tangent is the same thing as sine over cosine, so maybe I plug that in and hope that that unlocks something about my problem. Okay, so coming down here, if I rewrote that tangent as sine over cosine, what would this allow me to do? And so then I'm looking at it and I go, oh, well, I do know that dividing by a fraction is the same thing as multiplying by its reciprocal. And so maybe instead of saying divided by sine over cosine, I say times cosine over sine. Okay, well, that allows my sines then to cross simplify, leaving me with cosine x. Okay, the reason we're doing number 13 last is it's probably the one that's a little bit, I would say probably the trickiest in terms of just the variety that there is in terms of routes through this problem. The other thing is it's going to be the only one that doesn't actually simplify down to one trig. Okay, it simplifies down to 2. Okay, so go ahead and pause this video, give this one a shot, and restart it when you're ready. Okay, in this one, routes that people took in class, we had some people who chose to rewrite all their secants and cosecants as their respective reciprocals. So cosecant being 1 over sine, secant being cosine, or 1 over cosine, that kind of thing. So you might have chosen that route. We had some people who chose to distribute the sine secant theta in and simplify from there. Both work, both obviously take very different routes through the problem. When I did this one, I did, initially speaking, rewrite as reciprocals myself. And then I didn't do any simplification initially as I rewrote. I simply did just take the secant, the cosecant, and the secant in the denominator here, which technically speaking 1 over secant. And I rewrote each of them as their respective reciprocals. So that means the secant theta then, and up top here, the secant theta, I'm going to rewrite that one as 1 over cosine theta. The cosecant theta, I'm going to be rewriting as 1 over sine theta. And then the secant theta that's in the denominator is technically this guy, 1 over secant, which I'm going to be rewriting as just cosine. Okay, so then coming back down here, the secant theta is going to be 1 over cosine. The cosecant, I'm going to rewrite as 1 over sine. And then the secant squared that's in the denominator, which is technically speaking 1 over secant squared, is going to be rewritten as just cosine, or cosine squared in this case. Okay. And so then once I did that, I then distributed in. And for some people, they like doing the distribution or multiplication all in one step. You can do that if you'd like. Or if you wanted to, you could, initially speaking, just rewrite following the distribution so that you can take a hard look at what you got left. And so maybe you want to rewrite it so you can take a close look. Looking at this. Okay, so what else could happen here? Well, a lot of simplification that could happen. The cosines could simplify. I've got some sines that could simplify. And a cosine with one of these two cosines could simplify, which leaves me with sine theta plus cosine theta. Okay. So that's objective 2. Again, if as you were working through this, you chose to route through the problems and weren't able to get the right answer, snap a picture, send it to me, I'll check it for you. My best recommendation again is to cut yourself some slack, have grace for yourself, try a route, and if it seems like it's getting complicated, then back up a little bit. Try a different route through the problem. See if there's a different identity you could plug in, or could you rewrite as sines and cosines or use reciprocals. But don't feel bad about backing it up and trying a different route. You might have more success going a different way through the problem. Okay, that's objective 2.